So remember on these, I'm telling you, you need a rough sketch. Right? I'm not checking exact points on there. I know a square root looks like this. If you forget what a square root looks like, then definitely pick points and figure it out. What would the plus 4 do? Up 4. All right, and then you were just telling me the range, so that's bottom to top, so 4 to infinity, so that one is B. C, x squared, what does that look like? What would a minus 16 do? Domain, as you go from left to right, keeps going in both directions, so that is A, negative infinity to infinity. D, we also have a parabola. What would the minus 1 do? Down 1. So my range from the bottom up, negative 1 to infinity. E, what does a cube root look like? A chair is x cubed, so the cube root is like that sideways chair. Okay, so it's flattened out like that. What would a minus 2 do? Right 2. Inside does the opposite, so subtracting moves it in the positive direction. But domain still goes forever in both directions, so that's everything. This one, same parent function. What's the plus 2 do? Up 2. But it's still going to keep going up and down forever, so still negative infinity to infinity. G, what's an absolute value look like? What's the plus 3 do? Okay, domain keeps going, so negative infinity to infinity. Range of this one, so we have the absolute value, which is the V. What's the minus 3 do?
Move it down.
And so my range bottom to top is F, negative 3 to infinity. I, so our parent function is a parabola. What happens on this one? Okay, what's my domain of that? That's the range. All right, 2x squared. So here's x squared. What does the 2 do? It's a vertical stretch, so it gets skinnier. So the range of that is 0 to infinity, which is D. So if I were to put this on the test, I am checking that you have the right graph. In your graph, I'm just looking at the basic shape and your transformation. And then I would check if you had the correct domain and range. Are there any questions about those? Okay. Number 2, this is just telling me in words what our transformations are. What happens with a negative out in front? What does a plus 4 do? And a plus 2? All right. Did I do this one with you yesterday?
Yeah.
I thought I did. Okay. So, there are 2 ways of doing this. On the test, you have to be able to do one of the 2 ways. I don't care how. The algebraic way is by testing the equations. And when we did this, we spent a whole day talking about what it means to be symmetric. If you are symmetric across the x-axis, then if you think about it on a graph, 1x gives you a positive and negative y. So what we did is we plugged in a negative for our y. Is there anything you can do that turns that back into the original? No. So this is not the same as the original. So it is not symmetric to the x. To check the y, if you're symmetric over the y, you have positive and negative x give you the same y value. So you always plug in a negative for the opposite variable. We make our x negative. When you take a negative squared, it becomes positive. Is that what we started with?
Yes.
Origin is both the y and the x. The x one drops off, but this one doesn't, and that's not what we started with. So you can choose to check all 3, like this. The other option is to use a graph. Okay, is this one that we could figure out the graph of? Yeah. X squared, we know that's just a parabola. So it's just looking like this. What does the 3 do to our parabola? Yeah, it's like a vertical stretcher. It makes it get skinny. And what's the plus 7 do? Okay, so I'm not making a real accurate graph, but I have a skinny parabola that's been shifted up 7. Can you tell if I fold that thing over the x-axis? So if I fold it over the x, it would come down here. Is that the original? No. If it's symmetric to the y, if I fold it over the y, so if I take this piece and fold it over the y, it overlaps, so that's my guess. Origin says first you fold over the y, then you fold over the x, so it still ends up down here, and that one is a no. So for symmetry, you can do the algebraic by plugging in negatives for the opposite variables, or you can draw a graph. I do expect, remember, it can have multiple types of symmetry, so you have to tell me yes or no on all of these. Okay, so each one gets an answer. Is that okay? All right, then we get down to our graph. And I told you to draw a parent function when we could. So number 4, you need a parent function. This could be also written as the absolute value of x plus 1 plus 3. The 3 was in front, but it doesn't matter, I'm just adding. So my parent function is the absolute value. If I'm giving you a graph, I expect at least 3 exact points. And we know we can get those just by a t-chart. Absolute value of 0 is 0, 1, 1, negative 1, 1. What are my transformations? What's the plus 1 do? Inside is x and outside is y. So what's the plus 3 do? So I take each point that I plotted, up and left. If you really got confused, could you plug numbers into this and see where they end up on your graph? Absolutely. So you can double check yourself if you get confused. All right. Any questions there? Number 5. That is not one that we can do a parent function for. That was a t-chart. We know that symbol means the greatest integer. So remember, if it falls in between 2 integers, you always give me the smaller one. So if I put in a 0, 1/3 times 0 is 0, minus 1 is negative 1. So 0, negative 1 is a point on my graph. Then we usually did decimals, like 0.5, 0.9, 1. If I put in 0.5, 1/3 times 0.5, it's like 0.16. 0.16 falls between 0 and 1, so what are you going to get out? 0. And then we have a subtract 1 on the end, so 0 minus 1 is still negative 1. If I put in 0.9, okay, we get a decimal. I don't know what it is exactly. So you're still getting your decimal. 0.3 falls between 0 and 1, so we get out the smaller one, which is 0, and then subtract 1 and we get negative 1. If I put in 1, 1/3 times 1 is 1/3. 1/3 falls between 0 and 1, so I'm still getting out 0. Minus 1 is still negative 1. If I put in a 2, that's 2/3, or 0.6 repeating. Greatest integer of 0.6, still 0. Minus 1 is still negative 1. But when I put in a 3, 1/3 times 3 is 1. Minus 1 is 0. So 3, it jumped up to 0. I was down here before. So we put an open circle underneath to end that step. And then we know the pattern. It's 3 units long, closed on the left, open on the right, and jumps up 1. A minimum of 3. But you could certainly go all the way if you wanted. It's your soothing music for the day. I requested that for you guys. I hope that makes you happy. All right, number 6. How do we graph these? Yeah. Anytime you have a piecewise, I want a t-chart for each piece. I want everybody to pay attention here because we're still making mistakes when we graph these. You always, always, always have to plug in this number. I have to put in 0, but it didn't have an equal to, so when I graph it, it would be open. Then we need things smaller than that, so maybe a -1 and a -2. Alright, so the opposite of 0 is 0. Opposite of -1 is 1. Opposite of -2 is 2. So I have 0, 0 is open. -1, 1. -2, 2. This kept going for everything less than 0, so it keeps going to the left. That's the first piece. Second piece, what do we have to plug in? 0. It has an equal to, so that one's closed. And then we need things greater than 0, so maybe a 1 and a 2. So if you put in 0, you get 0, 1, 2, 2, 4. If you have an open and a closed circle at the same spot, it just becomes closed. So 0, 0 is closed. 1, 2, 2, 4. And it kept going. So it looks like that. All right. Any questions there? All right. Number 7, you would need a parent function on this one. If you need to, you can talk through it for your parent function. Just think about the t-chart. Can you do the square root of negative numbers? No. So we start at 0. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. If you wanted the square root of 9 is 3. Have to have at least 3 points. And then our parent function is dashed. Sometimes stretching and shrinking was hard. These are the points I just grabbed. The trick I told you was anything on the outside changes y, and it does what it says. So that 3, it's a vertical stretch. It's going to take my y's times 3. 0 times 3 is still 0. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. What will the -2 do? Right, 2. Okay, so I'm here at 0, 0. When I stretch, it's still at 0, 0, and then we went right 2. 1, 1, according to this, becomes 1, 3. I took the y times 3, and then right 2. 4, 2 became 4, 6, and then right 2. 9, 3 became 9, 9, right 2. So you get the same shape, but it is taller because we stretched it, and it's been shifted over. Is that one okay? Number 8, how would I graph that? T-chart for each piece. On the first piece, what do I have to put in? Open or closed? And then what other numbers? So then we're putting them into the 2 plus x. So 2 plus -4 is -2. 2 plus -5 is -3. 2 plus -6 is -4. So -4, -2 is open. -5, -3, -6, -4. And that kept going for everything less than 4, so it just keeps going with an arrow. The middle piece, what do we absolutely have to put in? And you can do something in between. Are those open or closed? The 2 doesn't have an equal to, so that one's open. All right, and I'm getting out the opposite of x. So the opposite of -4 is 4. Opposite of 0 is 0. Opposite of 2 is -2. So -4, 4 was closed. 0, 0. 2, -2 is open. And this had 2 endpoints, so that means there's no arrows. It just goes from here to here. Whoops, I plotted this point in the wrong spot, didn't I? Should look like that. And then the last one. What do we have to plug in? Open or closed? Closed, because that's an equal to, and then we need things greater than that. So maybe a 3 and a 4. So 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12. So 2, 6 is closed. 3, 9, 4, 12 is off my graph, but this is enough. So I know it goes, and it keeps going because it's for everything greater than 2. Make sure, these are functions. It starts out f of x equals, so it has to pass the vertical line test when you get to the end. If it doesn't, you've made a mistake somewhere. Number 9, we could do a parent function on this one. X cubed, so 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. Negative 1 to the third is negative 1, negative 2 to the third is negative 8. So that's my pair. All right, my transformations. What will a negative in front do? Already x. And the minus 4? Okay. So if you need to, you can write out your points. The negative on the outside just changes the sign on your y value, so we can talk through it. If you're at 0, 0 and flip over the x, it stays there. Down 4. 1, 1. If you flip over the x, it goes to 1, negative 1. Down 4. 2, 8. If you flip that, it goes to 2, negative 8. Down 4 is off my graph. Negative 1, negative 1. If we flip it, it goes to negative 1, 1. And then down 4. Negative 2, negative 8. If you flip it, it goes to negative 2, 8. Down 4. Minimum of 3 points. Parent functions are expected on everything except piecewise and greatest integer. Any questions there? Let's keep going, see how much we can get through. On these, we are just doing function operations. So g minus f of x. So g of x is 4x plus 4 minus f is 3x squared minus 2. Distribute your negative, combine like terms, so you get negative 3x squared plus 4x plus 6. Order doesn't matter, you just have to have all those pieces. 11 is asking for f times g. So if you FOIL, you get 12x to the third plus 12x squared minus 8x minus 8. Number 12, what do you have to do? Plug in 0 for both. If I put it into f, 0 minus 2 is negative 2. If I plug it into g, 0 plus 4 is 4, so negative 2 plus 4 is 2. Oh, you did a composition. All right, 13 is asking you to put negative 2 into each and divide them. So on the top, 4 times 3 is 12, minus 2 is 10. On the bottom, negative 8 plus 4 is negative 4, so we should get negative 5 halves. Number 14, the domain of g divided by f. First, let's write down g divided by f. G is 4x plus 4. F is 3x squared minus 2. We have done a lot of domain stuff. When you have a fraction, what do you have to think about? Denominator can't be 0. So 3x squared squared can't be 2. So x squared can't be 2/3. How do you get rid of a square? Well, that's what a square means. So the opposite would be a square root. And anytime you add a square root, you get a plus and minus. So x can't be plus or minus the square root of 2/3. You could simplify it and write it differently. If it's more than one value, you can list it. Remember, if it's just one, I do expect the interval. So you could leave it like this. Number 15, g composed with f. So function f is 3x squared minus 2. I'm putting that into g. G is 4 times whatever we put in plus 4. So we get 12x squared minus 8 plus 4. So 12x squared minus 4. Is this helping you guys to go through everything? Okay, are you fixing mistakes as you come across them? Any questions? Number 16. I am going to have one of these on the test, but it will not be written like this. I'm going to do a 3-step. I'm going to say part A, find f of x plus h. Part B, do f of x plus h minus f of x. Part C, f of x plus h minus f of x over h. So it will be an ABC question on the test. F of x plus h says you go to function f and you replace the x with x plus h. X plus h squared means you have 2 of them. So you have to FOIL that. So you get x squared plus xh, and plus xh would be plus 2xh plus h squared. Distribute our 3. So we get 3x squared plus 6xh plus 3h squared minus 2. Part B, you take that answer and we subtract the original f of x. To subtract that, you distribute your negative. 3x squared and negative 3x squared cancel. Negative 2 and positive 2 cancel. So all we're left with is 6xh plus 3h squared. Part C, we take that answer and divide it by h. So if I take an h out of each of them, I get 6x plus 3h. That is a little bit longer. What questions do you guys have there? Number 17. I told you in class yesterday my D was supposed to stand for domain. So the domain of f. F is a fraction. What do we know about a fraction? Bottom can't be 0, so x can't be 5. Since it's just one number, I do expect the interval. Draw a picture if you need to. It can't be 5, so that means it could be smaller than 5, it can be bigger than 5. So it would be negative infinity to 5 with the parenthesis because of the not equal, union 5 to infinity. On B, if we have a radical, what do we have to do? The inequality, the thing under the radical greater than or equal to 0. So x is greater than or equal to negative 6. Okay, so if you think about that, what that means, it's saying equal to is bracket, everything bigger. So our domain is bracket negative 6 to infinity. All right, C. This one is not very pretty, but what do we do first? So f of 1.5. So function f would be -2 over 1.5 minus 5. What do you get when you put that in? So -2 divided by -3.5, which I think turns into 4 over 7.
Yep.
Okay, then I put that into g. So that's the square root of 4 over 7 plus 6. This does not work out nicely. If you write it, you could say the square root of 46 over 7, or if you got a decimal, 2.5635. That one just didn't work out very well.
Yeah, I didn't have that, so I couldn't do that. I stopped at 4 over 7. Yeah.
Oh. So D, g of -2, if I put a -2 into g, that gives me the square root of 4, which is 2. So now I put a 2 into x, so -2 over 2 minus 5. So -2 over -3, or positive 2/3. Number 18, what are you being asked to do? All right, so change your x's to a -5. Watch your negatives. -5 squared is 25. The negative in front makes it -25. -7 times -5 is positive 35. Minus 22. So -12. All right. Number 19. There will be one of these on your test. Okay, and it's going to be multiple points because you have to do the composition and find your domain. G composed with f means g of f of x. So that's g of 3 over x. If I go to my function, that's 5 over 3 over x minus 1. Can you leave it like that? No. So we took top and bottom times x, so we didn't have a fraction in a fraction. So we get 5x over 3 divided by x times x is just 3, minus 1 times x is x. That's my composition. For the domain of these compositions, you had to look at the final piece and the original inside. When I look at this inside, I have a fraction, so I know the bottom can't be 0. Over here, I have a fraction, so the bottom can't be 0. So I get that x can't be 0 or 3. If it were just one value, I expect intervals. Since it's 2, you can list them. So our domain, we cannot have 0 or 3. All right. Is this going okay? Let's go ahead. I'm going to jump down to the bottom. I'll go back up to those 3 questions if we have time, but we've already done a graphing of piecewise. We've already talked about domain of range of our transformations. So I want to do some that we haven't done yet. Remember absolute value equations? You always get the absolute value by itself, which here we have 1 on each side. So your 2 equations, the first one, nothing changes. The second one, you set it equal to the opposite. So over here we would get 4x equals -12. I subtracted over my 3x and subtracted my 11. So x is -3. On this one, it'd be 7x plus 11 equals -3x plus 1. So if you add over your 3x, you get 10x. Subtract your 11, you get -10. Divide and you get -1. So my answers are just these 2 numbers, -3 and -1. 24, what would you have to do first? You have to get the absolute value by itself. Then you make your two equations. 4x plus 3 equals 1. 4x plus 3 equals negative 1. So if we solve those, we subtract the 3, divide by 4. We get negative 1/2. Over here we get negative 1. So it's just those two answers. Don't write them in parentheses. That looks like it's an interval. It looks like you're telling me everything between them. Did you guys get the equations? Then the inequalities. You have to ask yourself, are these and or statements? When you see a great or, that's an or. We did two pieces. The first one, you just drop the absolute value, or the second one, you drop your absolute value, flip the inequality, and make it a negative. So if we solve both of these, when you divide by a negative, that flips the inequality, so you get x is less than or equal to 5/3. On this one, flip your inequality because you divide by a negative, so x is greater than or equal to 3. Number lines can help you if you need it. Less than or equal to 5/3 is everything from 5/3 and smaller. Greater than or equal to 3 is everything bigger than 3. Or should have two pieces, so we write the interval. Negative infinity to 5/3 with a bracket, union bracket 3 to infinity. So greater than is an or, you get two pieces at the end. On 26, what do we have to do first? Right. Before you decide and or and make multiple inequalities, you have to get the absolute value by itself. So now, it's less than. What does less than mean? And. There are different ways. You can still solve the two separately, but I found that when you do it, you're not writing your answers correctly. So what I always do is I just put it, the and, I make one big inequality, because I know it's just in between two numbers. So it's this inequality, you put another less than or negative 5 on the other side. So then we solve that. Subtract 2 from all pieces. Divide everything by 5. So we get negative 7/5 is less than, x is less than 3/5. This is always, an and is in between two numbers. X is bigger than negative 7/5 and smaller than 3/5. No equal to, so parentheses. So and we get one interval at the end. All right, do you guys see the difference between and or? 27. Before I decide and or, what do I have to do? Divide by a negative. When you do that, it flips your inequality. So is this and or? And. I do negative 3, less than x minus 4, less than 3. So if I add my 4 to everything, get 1, less than x, less than 7. So it's just everything from 1 to 7. The absolute value is by itself and there's a negative over here. So don't solve it, just think about it. When is a positive number less than a negative number?
Every time.
So this one is a no solution. Positive numbers are bigger than negative numbers, not smaller. Okay, so there will be several of those equations and inequalities on the test. Are there any questions? Inequalities, I do expect the interval notation on those. Yes?
Back on 17, part C, how did you get 46?
That was not.
On part C?
Yeah.
Okay, so you put 1.5 into G. So you get negative 2 over negative 3.5. If you put that in your calculator, it gives you a fraction, 4 over 7.
Okay.
Then you're putting that into G. So that's when it goes under the square root. Any other questions? Okay, let's go over these couple that we skipped. All right, any piecewise function, how do you graph them? Teach. Yeah. Plug in numbers. All right, what do I have to put into the first? 4. Will it be open or closed? And how do we know that? Okay, and then what other numbers would we do? Okay, so if I put in a 4, 8 minus 3 is 5. If we put in a 3, 6 minus 3 is 3. If I put in a 2, 4 minus 3 is 1. So 4, 5 is open. 3, 3, 2, 1, and it would just keep going because it doesn't have an endpoint. Second piece, what do you have to put in? I have to put in a 4 again. Open or closed? Closed. And then we need things larger than that. Maybe a 5 and a 6. So if we put in 4, negative 4 plus 6 is 2. If I put in 5, negative 5 plus 6 is 1. If I put in a 6, negative 6 plus 6 is 0. So 4, 2, 5, 1, 6, 0. Okay, that's my graph. These questions, you can use the graph or you can just use the definition to help you. We can look at our graph and see when x is 4, what do we get out? Or we can ask ourselves, if x is 4, which piece are you plugging it into? The top or the bottom? The bottom. And so you get negative 4 plus 6, which is 2. If x is negative 6, are we putting that into the top or the bottom? Negative 6 is less than 4, so it goes into the top. So negative 12 minus 3 is negative 15. If I put in 5, which piece do you plug that into? The bottom, because 5 is bigger than 4. So we get negative 5 plus 6, which is 1. So for those, it's just a matter of knowing which piece to plug them into. Then I asked you some questions about the graph. Increasing, decreasing, constant. What does my graph start out doing as I go from left to right? Increasing. You always give me the x's here. So my x is coming from negative infinity. It stops when I get to 4. Okay, and it had an open circle, so it would have to be a parenthesis. Remember, the 4 is my x. What happens after that? Decreases. Starting at 4 with a bracket because of the closed circle, keeps going forever. Is it ever constant? No, remember constant is just a horizontal line. Okay, continuous. That is, where can you draw this without picking up your pencil? Again, you use the x's. The only time you give me y's is if I ask for range. So as I'm drawing this, I can draw this whole piece without picking up my pencil, but then I have to move right here. So it's coming from negative infinity until I get to what x value? 4. Union, that 4 got a parenthesis because it was an open circle. If I start again at 4 and keep going, I never have to pick up my pencil again. So union 4 to infinity. This 4 be a bracket because it was a closed circle. So continuous is the x value. Where can you graph without picking up your pencil? All right, so that one asks a lot of questions about a graph. Make sure if I give you a graph, you could tell me where is it increasing, decreasing, where is it constant, where is it continuous. You always use x's in your intervals. The only time you use a y in an interval is when? The range. All right, so number 21. If I think about this graph, absolute value is my v. What's my transformation here? What's happening to it? It's flipping, it's going left 4, down 6. All right, I'm going to run out of space. So if I take that left 4 and down 6, here this flips, left 4 and down 6. This one flips, left 4 and down 6. So we're getting this upside down graph. What's the range of that? And the -6 would get a bracket. So it was upside down, that's why it's coming from negative infinity. And it was shifted down 6, so that's why it stops at 6. 22, even, odd, or neither. This is a lot like symmetry, except when it was written in function notation, it was easier. Even means when you put in a negative for your x, you get the original back. Odd means if you put in a negative for the x, you get the opposite back. So if I put in a negative, if you take a negative to the 5th power, is it positive or negative? All right, if you take a negative to the 3rd, it is negative times the -2 makes the whole thing positive. Okay, is that what I started with? No. Is it the exact opposite, like the original times -1? Yes, so that means this is odd. Opposite is odd.